Okay. Good afternoon. My name is Greg Kimmel. I'm here to discuss my final project, a web-based site suitability tool for the Marcellus well-pad placement in Pennsylvania. My agenda for the presentation will go as follows: introduction, project background, data used, model criteria, results, and conclusions. So I currently work for Seneca Resources Corporation in northwestern Pennsylvania as a senior geomatics analyst. My duties include map cartography, GIS database maintenance, GPS data collection, and field verification duties. My field verification duties include wetland delineations, access road routing, and well pad placement. I decided to create the site suitability tool as an approach to better communicate with Seneca geologists using GIS. This tool allows the user to search an area of interest and results in a georeference raster grid. The final raster depicts areas that are unsuitable for well pad development based off of government environmental regulations. The Marcellus Shale runs from New York south to West Virginia. According to Penn State University, there's approximately 1,500 trillion cubic feet of gas within the Marcellus Shale layer, of which 489 trillion cubic feet is considered recoverable. Until recently, the Marcellus Shale was not economical to drill, but with advances in hydraulic fracturing, the Marcellus has become one of the largest natural gas fields in the United States. This is a map showing where the core of the Marcellus Shale is within Pennsylvania and New York and West Virginia. Just a little background about Seneca Resources. Seneca explores for and produces natural gas from the Marcellus Shale. To date, Seneca has drilled and operates over 150 Marcellus gas wells, and Seneca operates in northwestern and north central Pennsylvania. My project background. As mentioned in my introduction, one of my many duties at Seneca is well pad field verification and access road routing. This process begins with the Seneca Resources Geology Department studying and mapping the Marcellus Shale layer at a subsurface level. Once the geologist has chosen a site for a well to be drilled, the coordinates are sent to the geomatics department for field verification. This field verification process involves physically going to a proposed well pad site and looking for the following features: wetlands, stream encroachments, steep terrain, threatened and endangered species habitat. The geologist's assessment for well pad location is based off of subsurface data. This means that from a geology standpoint, the pad location is not based off environmental surface features. This is why I decided to create a tool that shows the geologists where they can construct a pad based off of environmental regulations and the construction suitability. And this slide just shows Seneca's operating areas in 11 counties in Pennsylvania. So data used. For this project, I used several data sets from various organizations. The data that is used for this project resides in the Seneca Resources GIS database. The data sets in the table have all been published as feature services to the Seneca Resources GIS portal. And all of the data is in NAD 1983, Pennsylvania State Plain North, US foot. The table shown shows where the data came from and what the feature type is in. So the model criteria. The table on this slide shows the criteria for this model. I'll briefly describe each criteria. The streams and wetlands. Streams and wetlands are all governed by the Pennsylvania Department of Environmental Protection. Act 13 was passed in 2012 by the Pennsylvania legislature to create standard setbacks for wetlands and waterways. According to Act 13, all wells need to be at least 300 feet away from any wetlands and at least 150 feet away from existing streams. The site suitability tool is set to buffer any wetlands 300 feet and any streams 150 feet within the user-defined area of interest. Threatened and endangered species habitat. Threatened and endangered species are governed by several state agencies and the U.S. Fish and Wildlife Service. These four agencies make up the Pennsylvania Natural Diversity Index. A majority of the T&E species that Seneca Resources deals with is the timber rattlesnake. Habitat loss is the driving reason that the timber rattlesnake is listed. Habitat for the timber rattlesnake includes rock outcroppings, open tree canopy areas, and boulder fields. The Pennsylvania Fish and Boat Commission, who oversees the timber rattlesnake and all reptiles and amphibians, enact a 300-foot buffer around all potential rattlesnake habitat. And finally, the slope. Seneca Resources operates in north central and northwestern Pennsylvania, where the terrain varies from steep mountains to flat plateaus. A majority of SRC's mineral acreage lies within steep mountain terrain. This terrain poses a unique problem when constructing a well pad. Based off of economics and guidelines set forth by the Seneca Resources engineering staff, a well pad should not be constructed in an area that is greater than 20% slope. Areas above this threshold result in disturbing more area and thus costing more money to move the excess material. The model finds all areas that have slope greater than 20% and includes this in the final unsuitable areas raster. And this is just a diagram of the model I created to come to my results. And there's a test project area. Seneca Resources, or Seneca's GIS portal data resides in our Pittsburgh office. Because I work in a field office, there's a small lag time when working with the data in Pittsburgh. So for this project and presentation, I decided to create a test area for the model just to allow for quicker results during my analysis. And this is a map of the test area that I worked with for this project. It's a section area I field verified a couple weeks ago. And and running the tool was published as a geoprocessing service to the Seneca Resources GIS portal, and just simply the user draws a polygon around the area of interest, and a georeference raster grid is created showing the areas that are unsuitable for well pad development. And next couple slides, I'll show you some screenshots of what it looks like. So this is the main page. That's my test area, the little square, my area of interest that I worked with for this project. So what the user will do, they'll open the web map, and they'll click the geoprocessing button that I have in the web mapping application, and a pop-up will come up asking them to grab the polygon tool. And the user will click the polygon tool, and they'll draw their area of interest wherever they're looking to put a well pad. And once they pick their area, they just click the execute button to run the tool. And once the tool runs, it'll bring up a link to the results, and the user just clicks the link, and they can either open it up just to see the results, or they can click the save button, save their computer. And that's the results from running from this tool. And I'll do a quick demo. Like I just showed you, the screenshots, the user will open up the web map. They will come click the geoprocessing button, and the pop-up comes up. They'll choose the polygon tool, and they just draw wherever they're thinking about putting a well pad. Click the execute button. It takes about 20 seconds or so. And there's your results. Just click the link, and I'll ask you if you want to save it to your computer, or I'll just open it just to show the results. And there's the results. All the black areas are unsuitable. It's either, there's either stream or some habitat or wetlands or slope that's within the black areas that they need to stay away from. So all the white areas are okay to place a pad. So my results, once the tool has been run, the user has the ability to save the raster grid to his or her desktop. The resulting raster is georeferenced and can be added to either ArcGIS desktop or geographic software. Our geologists use geographic software for their analysis of their geological data. The raster shows all areas that are unsuitable for development based off of environmental regulations and construction suitability. The tool can be run as many times as the user wishes, and the results overwrite each time the user draws a new polygon. So my conclusions, the initial tool resulted in exactly what I was hoping for when I first started the project. The results will provide a visual image of where well pad can or cannot be developed. The tool will also benefit myself, because I can run the tool and see where the unsuitable areas are before I even step foot in the field. So also the ability for geologists to add the data to geographics will help minimize steps in converting files from GIS format to geographics format. And some future updates. I'd like to add more features, such as like public water sources, springs and water wells. We deal with some of that when we get around houses and towns. Maybe add more flexibility between feature types. An example would be the ability to choose a buffer type based off of a certain teeny species. Each species has different buffer distances. For this project, I used the rattlesnake because that's probably 99% of what we deal with in the field. Maybe create the model in Python script, and maybe create a web mapping application that adds the results directly to the web map, so you can use it right in your web map. And after initial release, gather feedback and what to add or remove from the users that have been using it. These are my references for the project. That's it. Some questions, comments, feedback? Thank you.
Okay, thanks, Greg. Let's give Greg a round of applause. Okay, so are there any questions? Okay, Greg, I have a question. How did you select your test area?
It was mostly just because I've been to the area, and I knew the area just because I was there. And we were actually we were looking to put a well pad in that area, so I figured I'd just use that area. So.
Okay, thanks.
Brian Cunningham here with a quick question. I'm also in the oil and gas industry as well. Has any other methods been used? Is there any desktop side software aside from history that's used in oil and gas for a similar process?
I'm sorry, I can't really hear the question.
So the question was, are there any other desktop type software that's used? Because Brian's also in the oil and gas industry. Is that about right?
So you mean like geographics or something? Is that what you're asking, or?
Yeah, does geographics have the capability?
Yeah, I'm not very familiar with geographics. I know that it can take shape files and stuff, and I know they can bring in raster grids like the one that's created from this tool. So if that answers the question.
Brian also mentioned that there's some third-party software. So what example? Blue Marble is desktop side only. Brian was just curious.
I'm sorry. I thought you were talking to them. No, I
Brian
don't.
was just suggesting some other sources.
Oh, okay. Sorry.
So to repeat the question, integrating what you've done with some other economic analysis would be kind of a good next step.
Okay.
But it wasn't in your list. What are your thoughts?
Yeah, because I mean, when we deal with building pads, we're moving a lot of dirt, and you have a lot of economics bringing stone in. So with the slope, that would help us without eliminating having to move a bunch of excess material. So I mean, yeah, just something like that. So.
Okay, that works. Anyone else?
Any other questions from online? Okay, so thanks again. Let's give Greg another round of applause.
Thank you.
So thank you everyone for joining us. Please remember that we will have some more presentations tomorrow, starting at 5 o'clock Arizona time. And so everyone should have the link for those presentations. And we look forward to seeing some great presentations tomorrow. And we want to thank our presenters, Amanda and Greg, and also everyone who has attended the presentations today. So we hope to see all of you tomorrow. Thanks.